Not only have the British been pioneering cave exploration and have almost certainly explored more cave than any other nation around the world, but we've also been pioneering in cave science, and there's wonderful, wonderful cave science going on, as you will hear in a moment, and you will hear over the weekend when there's cutting-edge British cave scientists presenting. So without further ado, I'll hand over to Gina, a young cave scientist who is leading the field at the moment. Gina.
Good evening, everyone. My role this evening is to talk about cave science today, and if you stick around for the weekend, there'll be many more cave science talks, and Tim Atkinson will give the overview of cave science over 50 years on Monday night. And cave science is a very glamorous profession, as you can see here. This is what attracts so many of us to this profession. And this is a map, it's an overview really of all the institutions in Britain that are doing cave science in some form or other today. And then a few of us have also made it abroad, so I'm in Austria and there's a whole bunch in Australia and America and other places. And I apologise to anyone that I've missed off. And cave science is very interdisciplinary. We work on a range of topics including hydrology, biology, microbiology, paleontology, archaeology, cave monitoring, structural geology, landscape development and climate change. And of course tonight I don't have time to go into all of these different topics, and so again over the weekends there'll be many of these discussed in a lot more detail. So I'm going to really concentrate on just a few case studies that I find interesting and that are really at the cutting edge of cave science today. And given the occasion, I thought it would be very apt to start with the 1977-78 Royal Geographical Society expedition to Mulu. And this is a copy of the cover of the first report from back then. And there's a quote in there that says, "Many of the caves are very old, and exact age cannot be ascribed to them, but 1,000,000 years is not untenable for the oldest." And of course, dating caves is an extremely hard thing to do. And Andy Farrant, who's here tonight and will talk tomorrow, did some work in the mid-90s. He worked on the sediments in the caves in Mulu and made some advances in this respect with dating the caves. And of course that's not Andy, but I don't have a photograph of Andy to hand. So Pete Smart from the University of Bristol and myself have used a more modern technique in recent years called cosmogenic burial dating. And this works on the principle that the Earth's atmosphere is bombarded with cosmic radiation from outer space constantly. And if this radiation hits quartz, which there's a loss of on the surface in Mulu, then the oxygen within the quartz will turn to beryllium and any silicon will turn to aluminium. The quartz then gets washed into the caves where it's shielded, so the roof of the cave will shield the quartz from cosmic radiation, and this production of aluminium and beryllium will stop. But then there's another twist to the tale, because this particular type of aluminium and beryllium is radioactive, and it will decay with time. And so I promise there's not many graphs in here, even though it's a cave science talk, but this demonstrates how this aluminium and beryllium decays with time. And so across the bottom we've got age, we've got 0 back to 6,000,000 years ago. And at time 0, this is when the quartz gets washed into the cave and it's shielded from the cosmic radiation. This is when we have the maximum aluminium and beryllium. Then after about 700,000 years we have half the amount of aluminium left. After 1.4 million years we've got half the beryllium. And then with time it decays and decays, and after 4 or 5 million years there's not enough left to measure. But we can use this in Mulu. We can go into the caves. This is the Wizard's Wand in Hurricane Hole in Benaras, and as you can see it's nearly full to the roof in quartz pebbles that have been washed in from outside, so they weren't generated within the cave. And we can take samples of this quartz, extract the aluminium and the beryllium, and then back calculate when it was washed into the cave. And so Mulu has cave passages over many different levels. We have the current lowest level today, where the cave is actively forming, where the river is, and any quartz in here will have a 0 age because it's just been washed in. And then as you go higher up away from the river level, this is 1954, it's over 200 metres above the present river level, and this cave passage is at least 2.5 million years old. So that early statement about the caves being at least 1 million years old was not incorrect. And there are much higher level passages that will be many, many millions years older. So through the course of this talk, I'm moving from the tropics north. Now we're in the north of Africa, and I'm going to highlight some work that Mike Rogerson is doing at the University of Hull. And he's been working in 2 caves, one in Libya, Susa Cave, and one in Grotte de la Mine in Tunisia. And I'm sure you're all familiar with this picture. They're on the northern rim of the Sahara, and it's very dry there today. And this is a photo I took in 2010 when I accompanied Mike to Libya, so just before the revolution. And Libya is full of caves, I might add. It's the next caving frontier. And Mike and I were there. We were very excited to have the opportunity to go and explore some new caves for the first time. And we were stood looking over this huge dough line. We couldn't see the bottom. We were very excited. And we were told, our guide got a phone call to say, no more caves, not allowed to visit any more caves. So that also included show caves, so we were not allowed to visit those. And we were put on an organised tour of Roman and Greek ancient cities, which is very nice, but not what you want when you're on a caving expedition. And then we got caught up in the volcanic ash thing in 2010 as well, so that was quite an interesting field trip. So now Mike is working in Tunisia. It's a little bit more stable, easier to work in, with a Swiss colleague called Mark. And this is Grotte de la Mine. It's quite a sizable passage. We've got a person there for scale. And more importantly, really, is this feature on the right-hand side. And I know there are some people in here who aren't cavers because I've brought them with me. So this is a flowstone deposit, a huge calcite deposit, and it's similar to a stalactite or a stalagmite, but instead of forming from drips of water, it forms from very thin sheets of flowing water. And essentially, it means there must have been flowing water in this cave at some point. Now, Mike had been to Libya before 2010 and recovered one stalagmite from there. And that was dated to 3 growth phases, around about 33,000 years ago, 50,000 years ago, and 61,000 years ago. And this was published last year, actually, and now he's extending this record over the last 500,000 years using the samples from Tunisia. And this is quite important because these wet phases that we have in North Africa are important for the human migration story. And in these times of milder climate, this is when scientists, not myself, but scientists think that this enabled humans to migrate across the Sahara and out across the rest of the world. So this is quite a hot topic in the sort of human evolution field. So now onto slightly colder regions, permafrost studies. Now, permafrost accounts for 24% of the Northern Hemisphere landmass, and under the current rising temperatures, it's thawing very fast. And this, of course, causes problems for infrastructure that rely on solid ground or ecosystems. But perhaps more importantly is the fact that permafrost contains almost twice as much carbon as the atmosphere. And so as it thaws, it releases more greenhouse gases, such as carbon dioxide and methane. And so it creates this positive feedback. As the permafrost thaws, you have more greenhouse gases, it creates more warming, so then there's more permafrost thawing. As a result of this is quite a hot topic now, and scientists are really working to try and understand more about permafrost. And so there are 2 groups, British-led groups, if you like, working on permafrost studies from the aspect of cave science. And this is a cave from Austria, obviously not from the UK. Obviously we don't have anything like this in the UK today. But I'm using this as an example to show you an ice cave and now talk a little bit about ice caves. So not many graphs, I promise. So this is a graph that shows temperature across the bottom. This is cave air temperature, which, as many of you know, is stable. So we've got -6 degrees on the left-hand side and 12 degrees on the right-hand side. And cave air temperature is very roughly equal to the mean annual surface temperature, so the temperature above the cave. And then on the y-axis we have cave altitude, so we've got sea level at the bottom, 0, up to 4,000 meters above sea level. And then the black dots are where the different caves plot on this graph. And there's a few very distinct zones here. Yeah, as we would expect, the lower the cave is in altitude, the higher the cave air temperature. And the higher the cave is in altitude, the lower the cave air temperature, as you would expect. And this creates a temperature gradient of about 0.4 degrees per 100 meters difference in height. And now I'll go on to say that there's a few very distinct zones here. The pink one, where we have cave air temperatures above 0, you'll find a cave something like this. So we have water that enters the cave. It doesn't freeze, it stays as water and flows off. Then in the blue zone, where we have cave air temperatures below 0, you might have something like this. So these are giant hoarfrost crystals, and they form when you've got just moisture in the atmosphere. It condenses onto the cave walls and creates these huge crystals. And it's kind of like your freezer at home. It's this kind of how the crystals form. But then there's also a third zone on here, and this is where the caves have a temperature of 0 degrees. And today they're found at about 2,300 meters above sea level. And these caves will look something like this. And in this case, there's infiltration of water into the cave during the summer, but then the cave air temperature is 0 degrees, and so it freezes and turns to ice. And in this process, something very useful for us happens. So here we've got a cartoon of a body of water that's freezing, and it contains carbonate ions and calcium ions. As it freezes, those ions stay in the water, they don't go into the ice, so this pool of water gets more and more enriched, until finally it becomes supersaturated, and then calcite precipitates out of this solution. And this forms what we call cryogenic cave calcites, or CCCs for short. And these are a few examples. We've got both flakes and crystals, and they come in different shapes and sizes. They're really fascinating things. And this is a field that's only really been developed in the last 10 or 15 years, and we're only just starting to recognize them when we see them in caves. And so 2 years ago, this was all the caves in the world that were known to have CCCs. And it's a rather odd perspective, because we're looking right down on the North Pole. We've got the USA over here, Greenland, Asia around to Europe. You notice the UK has no red dots. There were no CCCs in the UK. And the blue zone, that indicates the maximum extent of the ice sheets at the height of the last ice age. And so 2 years ago, no CCCs in the UK until Robbie Schoen and Tom Chapman and myself went to Wookey Hole after Hidden Earth, and we were going to visit the newly open Wookey 20. And walking along, and Tom says to us, "Watch out for the white stuff on the floor. We don't know what it is, but we think it might be old bat guano." And we looked down, and this is what we saw. And I kind of went, "Oh yeah, okay," and just kept on walking. And Robbie went, "No, wait, Gina, look, it's CCCs," which any of you who knows Robbie is not very scientific, and I just ignored it, so it was quite wonderful, really. And we looked closer, and this is what we found. So different types to what I'd showed on the previous slide, and I've dated a few of them, and they all centre on about 14,700 years ago, which means that 14,700 years ago, Wookey Hole was an ice cave. And since then, we found them in Reservoir Hole in Cheddar Gorge, also in Miss Gracie's Lane in the Forest of Dean. And now the BCRA has funded a competition, and we're doing this caver-led citizen science and trying to encourage you all to look for CCCs. And so the competition has been running for 1 month, and the red dots are where we knew there were CCCs before, and the blue dots are where we've already had new finds in the last month. And the competition runs till the middle of next year, and there's lots of prizes of rope and caving equipment available. So check out the latest descent. There should be something in there. And now I'll just say a few words about the work that the University of Oxford are doing, also on permafrost, but they're looking at it from a different perspective. So they've been working in Siberia over the last decade in a number of caves. They have these caves with hoarfrost, so they're very much in the permafrost zone. But a lot of these caves also have these huge flowstone formations, indicating that there was flowing water there at some point. And so they've dated these deposits, and they found that the most southerly ones have thawed several times over the last 500,000 years. But the most northerly one at 60 degrees does not thaw as often, and the last time it thawed was about 400,000 years ago. And this work was published in Science, and now they are developing this work over the last 1.5 million years to really get a better understanding of permafrost thawing in relation to climate. Okay, so back to the UK, and now more specifically to Ebba Gorge, which, as many of you may know, Ebba Gorge is not typical of Mendip gorges. There's no road going through it, you have to walk through it. And most of the caves there were discovered by Victorian and Edwardian explorers and dug out. And so for there to be one cave that remained unexcavated was quite fantastic. And this is Gully Cave, which the excavations began in 2006 by Danielle Shreve from the Royal Holloway. And they go there every summer and spend 2 weeks there digging, and they've done that for the last 10 years. They've removed 120 tons of sediment and now uncovered a second entrance. And all of that sediment has been put through a very fine sieve to see what is left behind. And they've discovered a jaw of a water vole. This is a jaw of a wild cat, and then the big bone in the background is an auroch, which is an extinct species of cattle. This is a wild horse bone that's been excavated at the back of the cave, and all of these creatures are now found in like the Russian steppe, so cold climates. And then as they went further down through the sediment, they uncovered reindeer, so this is a young reindeer skull. And also a jawbone, and this was a very young reindeer because its milk teeth are still in there, which is what the two arrows point to, and then there's the adult teeth underneath. And then as they've gone further down, they found a brown bear den. So this is a molar from a brown bear that's very worn, a hyena jaw, and then also a brown bear bone that has been gnawed by a hyena, and that's what these scratch marks are on this bone. And this is now the best record of environmental change in the UK over the last 50,000 years, and one of the best ones for Northern Europe. Okay, and then finally we finish in the Arctic, so the last case study, the North East Greenland Caves project. And like all the best projects, this one started in the pub with Charlie Self, who I'm sure many of you were friends with. And he told me about some caves that had been discovered by the Americans in 1960. And they were up there in the height of the Cold War looking for places to ditch aircraft in an emergency in the Arctic. And this is just some of the remains of their activities in the Arctic. But their reports mentioned a flowstone in one of the caves, which was interesting because this region is very dry and the ground is frozen, so you can't form calcite today. And so I wanted to get a sample of this to find out when in the recent past Greenland was warmer than today, and what was the nature of the climate at that time. And so armed with this excellent map and photographs, I managed to put an expedition together somehow. It took 2 years to organise and raise the funds for. And then in July 2015, we all met in Iceland. We flew to Akureyri, chartered an aeroplane to Constable Point, up to Mestersvig, where we spent a few days sorting through equipment, up to Danmarkshavn for refuelling, and then continued up to Centrum So. We then inflated a boat, crossed the lake, set up base camp, and then walked for 3 days to get to the caves. So we set off, separated, made a kit dump. A few of us carried on and made an advance camp. Next day, we all met back at the kit dump and then carried on together to the advance camp. And this photograph on the bottom was taken at midnight, so that gives you an idea of what the midnight sun is like in the Arctic. We then made the river crossing and continued down this wonderful valley to get to the caves. Finally arriving there 8 days after leaving home, which was fantastic. And then we just had 3.5 days at the caves to do our work. We managed to find some of those original ones reported in 1960. We added another dozen to the total that was already known about. And we collected some fantastic calcite samples. So on the bottom here, we've got a sample where there's 2 stalactites that have broken, fallen down onto the floor, and then a flowstone has formed on top. We've got a flowstone that's so old, there's no cave left around it anymore. A flowstone that formed on some sediment, and then the sediment has washed away. And in total, we ended up with 16 samples of calcite, which was amazing, considering the whole expedition was based on 1. And preliminary results are very encouraging. We have growth between about 400,000 to 600,000 years ago, which is much older than the Greenland ice cores, which cover the last 128,000 years. So with these cave records, we're able to vastly improve the knowledge of Greenland's climate by constructing records for a different time period. So thanks to everyone who's provided material for this. So that's a round robin of lots of different work that's going on from different institutions. And also thanks to the 59 sponsors of the North East Greenland Caves project. And thanks to you. I hope you enjoy the rest of your weekend.
Thank you very much indeed, Gina. I know that gave you a pretty good insight into modern cave science, and there's an awful lot more to be discovered and done in that field in future.